Good morning, students. Today, we will discuss another method that is known as Gauss-Seidel iteration method. By using Gauss-Seidel iteration method, we can solve a system of linear equations. Here, the problem is, by using Gauss-Seidel iteration method, solve 8x1 plus x2 plus x3 is equal to 8. 2x1 plus 4x2 plus x3 is equal to 4. x1 plus 3x2 plus 5x3 is equal to 5. By using Gauss-Seidel iteration, we can find the value of unknowns x1, x2, x3. When we use this method, first we check the diagonal coefficients are dominant. That is, when we take the first equation, this is the first equation, we check the coefficient of x1. Here, coefficient of x1 is equal to 8. This coefficient is, when we compare with the other coefficients, larger than x2 and x3. Then we take second equation. Second equation, the coefficient of x2 is equal to 4. This 4 is larger than x1 and x3 coefficients. Then take the third equation, coefficient of x3 is equal to 5. This 5 is greater than coefficient of x1 and x2. First, we arrange the equations. The coefficients are diagonally dominant. This is the first step. After arranging, the coefficients are diagonally dominant. From the first equation, we can find the value of x1. The value of x1 is equal to 8 minus x2 minus x3 divided by 1 by 8. The second equation, x2 is equal to 4 minus 2x1 minus x3 by 4. The third equation, x3 is equal to 5 minus x1 minus 3x2 by 1 by 5. First, we construct x1, x2, x3. x1 in terms of x2, x3. x2 in terms of x1, x3. x3 in terms of x1 and x2. Then, by using iteration 1. Iteration 1. In the first iteration, we take x1 is equal to x1 raised to 0, that is equal to 0. Then x2 raised to 0, that is equal to 0. Then x3 raised to 0 is equal to 0. We assume x1, x2, x3 are zeros. By using these values, first we find out the value x1. That is 1 by 8 into 8 minus 0 minus 0, the value will be 1. Therefore, the value of x1 is equal to 1. Then, find the value of x2. In this equation, x2 is equal to 1 by 4, 4 minus 2x1 minus x3. That is 1 by 4, 4 minus 2 into. Here we substitute the value of x1 is not 0. Instead of that, we substitute the updated value. Updated value is 1. Substitute the updated value 1 here. Then x3 is equal to 0. Therefore, 1 by 4 into 4 minus 2 into 1. The answer will be 0.5. 0.5. Then find the value of x3. x3 is equal to 1 by 5. 5 minus x1 minus 3x2. 1 by 5 into 5 minus. Then we substitute the value of x1 and x2, updated value. Updated x1 is equal to 1 and x2 is equal to 0.5. Therefore, we get 1 by 5, 5 minus x1 is equal to 1, x2 is equal to 0.5. Therefore, our answer will be, simplifying our answer will be 0.5. Again, 0.5. This first iteration is over. Then we come to second iteration. Iteration number second. iteration 2. Then first find out the value of, this is x1 raised to 1, x2 raised to 1, x3 raised to 1. Then x1 raised to 2. To calculate x1 raised to 2, 1 by 8 into, our formula is x2 minus x3. Here we substitute x2 is equal to, the value of x2 is equal to 8 minus 0.5. 8 minus 0.5 minus x3 is equal to 0.5. Update value substituted here. x2 is equal to 0.5, x3 is equal to 0.5. Therefore, simplifying, you will get the answer 0.875. 0.875. Then calculate x2. x1 raised to x2 raised to 2. Using this equation, 1 by 4, 4 minus 2x1 minus x3. That is 1 by 4, 4 minus 2 into. Here x1 is equal to 1. Then x3 is equal to 0.5. 4 minus 2 into. Here x1 is equal to latest updated value. Here x1 is equal to, in this case, we substitute 1 by 4 into, x2 is equal to 1 by 4 into 4 minus 2x1 minus x3. 1 by 4 into 4 minus 2 into. Here we substitute the value of x1 is equal to 0.875. 0.875 minus x3 is equal to 0.5. That is, we substitute updated value. Therefore, 2 into 0.875 minus 0.5. The answer will be 0.4375. 4375. Then we calculate next value. Next value, x3 raised to 1. Next we calculate x3 raised to 1. Formula 1 by 5. 5 minus x1 minus 3x2. That is 1 by 5. 5 minus, here x1 is equal to, let's just update value, that is equal to 0.875. This is 0.875 minus 3 into x2 is equal to 0.4375. 0.4375. Calculating, we get the value 0.5625. Therefore, the value of x3 raised to 1 is equal to 0.5625. Therefore, x3 raised to 2. x3 raised to 2 is equal to 0.5625. Then we pass on to next iteration. Similarly, we can find the iteration number 3, 4, etc. Iteration number 3. We get the value. We are substitute the latest updated value. x1 raised to 3 is equal to, latest updated value we get x1 raised to 3 is equal to 0.875. x2 raised to 3 is equal to 0.4219. x3 raised to 3, 0.572. The iteration number 4, we get x1 raised to 4 is equal to 0.876. x2 raised to 4 is equal to 0.419. Then x3 raised to 4, we get 0.5734. The iteration number 5, x1 raised to 5 is equal to 0.876. x2 raised to 5, 0.419. x3 raised to 5, we get 0.5734. Then we do some more iteration. The iteration number 3, iteration number 4, and iteration number 5. When we check the iteration number 3, 4, 5, here x1 is equal to 0.875, here x1 is equal to 0.876, here x1 is equal to 0.876. The element is coincide. Therefore, we take the value of x1 is equal to 0.876. Then we check the next. Here, x2 raised to 3 equal to 0.4219, x2 raised to 4 is equal to 0.419, x2 raised to 5 is equal to 0.49. Therefore, x2 taken as 0.419. When we take the iteration 3rd, 4, 5, etc., this element is coincide. Therefore, x3 is equal to, here x3 raised to 4 equal to 0.5734, x3 raised to 5 equal to 0.5734. Therefore, the element is 0.5734. This is the solution of the system of equation. In Gauss-Seidel iteration method, first we check the coefficients of diagonal coefficients are dominant. After the diagonal coefficients are dominant, we find out the value of x1 in terms of x2, x3, x2 in terms of x1, x3, x3 in terms of x1, x2. Then find the value of x1, x2, x3. We create an equation for x1, x2, x3. Then iteration number 1, first we assume x1 raised to 0 is equal to 0, x2 raised to 0 is equal to 0, x3 raised to 0 is equal to 0. Substitute the first x1 raised to 1. Substitute the value of x1 and x2 are 0, 0. Then we get the value of 1. When we find the second value, x2 raised to 1, we use the updated value. In this case, we use x1 is equal to 1, not 0. x1 is equal to 1, not 0. x3 is equal to 0. Therefore, we get the value 0.5. When we find the value of x3, x1 and x2, x1 is equal to already find out 1 and x2 is equal to 0.5. We substitute here. In that manner, we find out the value of x1, x2, x3. We use the updated value. We use the each and every iteration, we use the updated value. Then we get first iteration, then second iteration, the third iteration, fourth iteration, fifth iteration. Some more iteration, we can easily find that the value of x1 coincides, the value of x2 coincides, the value of x3 coincides. Then we take the value x1 is equal to 0.876, x2 is equal to 0.419, x3 is equal to 0.5734. This is the procedure for Gauss-Seidel iteration method. Okay.